Sine function. Let me first of all point out something that it's not a mistake, but I kept telling you that my scale was pretty bad, and I wasn't sure exactly where my scale was bad. Pi over 2 is about 1.5, right? So if you look at what I labeled as 1, it should be like 0.5, right? In terms of my scale. So that was my, and also the height of the sine curve. This height here should also be like 0.5, because but my scale was really pretty bad. So I just wanted to start out with drawing a nicer version of the picture. And so again, in this picture I have the sine function between, the green one is the sine function between negative pi over 2 to positive pi over 2, and then between negative 1 and 1 I drew the graph of the inverse sine function. Okay, and this time my scales are much better. Of course, still there are some problems with the scale, but that's like the I can live with that, but I couldn't live with the other one, so that's why I made this one. Okay, so any questions on that? There wasn't any mistake, it's just the scaling was pretty bad. Okay. Alright, so just wanted to remind you that the graph of cosine function between 0 and pi is a decreasing function. The graph of cosine function between 0 and pi is a decreasing function. Because it is decreasing, it is 1 to 1, so it has a inverse function, and that's what your assignment was all about on the inverse cosine. So I won't say any more than that. Here's an example. So I think we did an example where we looked at the integral. Am I correct? The last example was the integral of 1 over root 4 minus x squared. Okay. So generally speaking, so last time what we saw was that if I look at the integral from integral of 1 over root of 4 minus x squared dx, and the answer we got was what? Sine inverse of half x plus c, right? Generally speaking, in general, I don't even want to call that a theorem, but if you want to remember it as a, well, let me not even call it an example as well. Let me just say this is a formula, but you don't have to remember it if you know how to derive it. This is 1 over a squared minus x squared root of that dx. That is equal to, can anyone guess what I would have within the parenthesis here? X over a, very good. Note that in the example I had a 4. 4 is like 2 squared, right? 2 squared, so that's why I have that half there. If I have a, that's what you're going to get. Now from this, can someone tell me what does it imply for the integral of 1 over 3 minus x squared root of that? What will that be? Sine inverse of x over root 3, right? Plus a c. Now the formula in red, how would you derive that? A is a fixed number there, so you're going to do a u substitution, right? What did you pick for u? Oh, yeah, you're going to do a u substitution. What would be u? So let me go to the red one. So how would I derive the red? Yeah, you take you take x to be au, right? So that means you take u to be 1 over ax, right? Is everybody okay? So the substitution, remember the goal is to sort of get rid of that a squared and replace a squared with 1, and then I know that the antiderivative is sine inverse, right? So you do the substitution, u equals to ax, and that would tell you that du is a dx, and also this is going to tell you that x is 1 over a u, right? Is everybody okay? So then if I do that substitution, my integral 1 over, let me write that down again, a squared minus x squared dx, this would be the integral of 1 over a squared minus, remember you're going to replace x by what? Oh, I'm sorry, I made a mistake here, sorry. What am I thinking? Did you guys see that, the mistake that I made? What I want is the other way, right? I want x to be a times u, which means u is 1 over a x, and it means that dx is equal to a du. Okay, so that's what I actually wanted. So in the denominator, I'm going to replace x by au. And I have a times du is dx. Okay, and then this is equal to the integral of 1 over a squared minus a squared u squared times a du, and this would be equal to the integral. Remember, the entire point was to introduce a squared as a factor of x squared. If I did that, then I can factor out a squared, and this would be 1 minus u squared a du. And now you can see that root of what's the root of a squared? The root of a squared, well, let's just assume that a is positive, okay? If I assume a is positive, root of a is just a. And then I have 1 minus u squared, I have root on it, a du. So what I'm doing here is that I'm assuming a is positive, okay? Otherwise, the square root of a squared would be absolute value there. So this is the integral of 1 over 1 minus u squared root of u du, and that is sine inverse. That is sine inverse of u. And then finally, we know that u is x over a. Okay. Is everybody okay with that? So in this formula, you need to assume a is positive. Otherwise, it's not going to work out the same way. Right. Yeah.
If a was negative, wouldn't it just be a negative at the time sine inverse?
Well,
Because when you cancel the a and a du, if it was negative on the bottom.
Okay, so generally speaking, A will not be negative. I can always assume A is positive because the number 4, the numbers like 4, is a positive. So you have to have a positive number there. Am I making sense? If you had a negative 4,
So that it's 1 to 1. So that sign is 1 to 1.
yeah. So I mean, your 4 here, if it is a negative 4, then you couldn't do what we did. You have to do something else. Okay, so because of that, if 4 is there, then the square root of 4 would be 2. We are looking at the positive root of 4. That's 2. Okay. Okay. Any other questions? Is that okay? Because you have in front of, so you have something positive minus x squared. So whatever the positive, you can write it as a squared, where a is positive, right? So if it is 4, it's 2 squared. If it is 16, it is 4 squared, and so on. Okay, so this is sine inverse of x over a. And one more example that I want to go over is the integral from 0 to a fourth, the root of 1 minus 4 x squared dx. And in this case, this is 1 over, I'm sorry. This is 1 over 1 minus 4. So in this case, once again, it looks very close to the derivative of sine inverse, right? Remember, the derivative of sine inverse is what? The derivative of sine inverse is 1 over the root of 1 minus x squared. So it looks very close to the derivative of sine inverse. So what should I do to make it look like derivative of sine inverse? Well, the problem is that factor 4 in front of x squared, right? And the question is, can we make it look like 1 minus u squared, right? So if my goal is to rewrite that as root of 1 minus u squared, what would you pick? What substitution would you do? What's that? Say it louder. 4x to be u? Close. Let me make maybe one more line here. So this would be 1 minus 2x squared, right? So I should be picking u to be what? 2x. So if I pick u to be 2x, then I see that du would be 2dx, right? And dx would be half du, right? So dx would be, I don't have to write it, but okay, so this is equal to, I am replacing 2x by u, so I get this, and I am getting what is dx? That's half du, right? Well, that half, let's change the limits of integration. When x is 0, what is u? 0. When x is fourth, u is, what's that? When x is a fourth, what is u? Half. Okay, so I can take the half outside, and this is 0 to half. and I have 1 over 1 minus u squared left. And now we know this is half sine inverse of u, half and 0. And what is sine inverse of half minus sine inverse of 0? We did those exercises before. What's the sine inverse of half? Could you say that louder? Pi over what? Pi over 6, right? 30 degrees. Sine inverse of half is the angle for which sine value is half, right? So sine of 30 degrees is half, right? So this is pi over 6. And what is sine inverse of 0? Give an angle for which sine is 0, right? Sine 0 is 0, yep. And so I get pi over 12 at the end. Did everyone see that? You guys are okay with that? Yeah. Which half you said?
From 0 to 1/2. Where do we plug 1?
Oh, so remember we picked u to be this, right? So this is the limits of integration for x. So when x is 0, you get u to be 0. When x is 1/4, you get u to be 2 times a fourth, which is half. Yep. And in the exam, I saw that some of you had mistakes like you did the right substitution, you changed the limits of integration, but at the end you went back to x again. Once you change the limits of integration, you cannot go back to the original variable anymore, right? That's why you change the limits of integration so that you don't have to go back to the previous variable. Am I making sense? So that mistakes, I saw that mistake made by a number of you, but it's not a big deal. It's just that keep that in mind in future.